Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Amirul Syaqirin. Okay, so today I'm going to explain to you guys on how to solve the assignment question for differential equation assignment question 1. Okay, as stated in the question, it has given us the value of x, which is equal to L over 2, and the value of u when x is equal to L over 2, u is equals to 1 over 2 BL. Okay, this is the main equation as given. X is stated is 0 is smaller than x and L is bigger than L. L is bigger than x and T is bigger than 0. Okay, so this is the equation UTT equals to A square USS. This is when we rearrange the equation. So next we have to change according to this slides. Okay, from the assumed solution, if it's du over ds, we're going to have to change it to x prime t d square u over dx square equals to x double prime t, and the same goes to for the t derivative t. So the main difference is we put the prime at t and the prime at x. So when we change it to this equation, it's gonna comes out as xt double prime over xt equals to a square x double prime t over xt. So this is the t derivative and this is the x derivative. That's why we have prime on x and prime over t. Okay, then we rearrange the equation. It's gonna come out as this one: t double prime over t equals to a square x double prime over x equals to p. And then we rearrange it again. So t double prime over a square t is equals to p. So we rearrange it again. So t double prime minus a square pt is equals to 0. And this is our final equation. So next is the boundary condition. The boundary condition is u at terms of 0 and t is equal to 0. So we just substitute the value. So tt is not equal to 0 and x0 is equal to 0 because of this equation. Okay. So ULT equals to 0, SL and TT equals to 0. TT is not equal to 0 and SL is equal to 0 based on this equation and also based on this equation. Okay, next is our case 1. Case 1 is when P is equals to 0. Okay, so we take the equation x double prime minus px is equal to 0 and then we just substitute it. So sx is equals to as plus b. This is because of our real and distinct, real and repeated, and also complex conjugate equation. So this one for p equals to 0, it is for real and repeated. So this is the equation for real and repeated, as plus b. So s when x is equals to 0, b is also equals to 0. So xl equals to al equals to 0. So a is equals to 0 after we rearrange the equation. So SS equals to 0. So UXT equals to USSTT equal to 0. Okay, for the second case, when P is larger than 0 or P is equals to lambda the power of 2, we're going to use the same equation, which is x double prime minus px equals to 0, x double prime minus, so we just substitute this p into lambda square, as you can see here, equals to 0. So we just rearrange and we change it to m square. Okay, so m square is equals to lambda square. So m is equals plus minus lambda, and then we just substitute the equation. This is the equation for when p is bigger than 0, which is real and distinct. Okay, so it's ae lambda m plus be negative lambda m. Why is it? It's supposed to be both positive, but why is it both? One is positive, one is negative. Is because m is equals to positive negative lambda. So this is positive lambda, and this is negative lambda. So we just substitute when x0 is equals to 0, x0 ae. So we just substitute the value from when x is 0 into the equation. As you can see, to m, so it's going to be 0. So anything is when the power of 0 is going to get 1. Exponent 0 is going to get 1. So a times by 1 is going to get itself. B times exponent 0 is going to get itself. So a plus b is equal to 0. So a is equals to negative b. So when x, the value of x is L, is equal to 0. So we're going to substitute the L into the equation. So ae L lambda, sorry, I'm going to zoom in for a little bit. So as you can see, lambda L lambda and negative L lambda. So since A is equals to negative B, we just change the value to negative B over here, as you can see. This is the A equals to negative B equation. We just change it, and then we just rectify it, okay, and then it's going to equal to 0. So when we rearrange the equation, so B is going to equals to 0 too. For case 3, when P is equals to negative lambda square, which is, for this equation, P is smaller than 0. So the third case is complex and conjugate. So we're going to use complex conjugate equation, which is over here. So the same steps all over again. S double prime minus P lambda. So we're just going to substitute P in this case is negative lambda square. So we just change it to negative lambda square. So we got X double prime plus lambda square. X equals to 0. So m square is plus lambda square is equal to 0. So m is also plus positive, negative, or plus minus lambda. So same steps as case 2, we just substitute the value x into the equation. As you can see, lambda x plus b sin lambda x. So when x is equal to 0, x is 0, so a cos 0, b sin 0. Cos 0 is going to get 1, that's why we're going to have a. Sin 0 is going to get 0, so this one is equals to 0, so it will be gone. So that's why a is equals to 0. So when x is equal to L and 0, so SL equals to a cos lambda L lambda, b sin L lambda, 0. We just change the equation, we just add on the equation. So 0 equals to 0 cos lambda L is equal to 0 since a is equals to 0. So a when equals to 0, so you're gonna multiply a with cos lambda, so it's going to equate to 0. So this equation is equate to this 0, and this equation is still b sin lambda L. So b sin lambda L is equals to 0, and then we arrange the equation b is equal to sin lambda L. So b is not equals to 0. Next is lambda L. So lambda L is equals to n pi. So lambda n is equal to n pi over L. So next equation is xn is equals to x, which is also equates to bn sin lambda n x, and then we just change the ln lambda n into this equation. That's why we're going to get this equation, which is bn sin n pi x over L. Okay, that's all from me. So next is Denish Kumar. He's going to continue to explain to you guys how to do this equation. And I think that's it from me. Thank you.
Very good morning. My name is Denish Kumar Akibaskarin. My matrix number is B0122102774. Today I'll be doing on the continuation of question 1. Now part 1 has already been done by Mr. Amirul Syaqirin, where he discussed on the case 1, case 2 and case 3. So let's move on part 2. So here we have the characteristic equation for G prime 2 minus with a square pg equals to 0, where p is equals to negative lambda square, and what we get from that is m equals to a minus a equals to m equals to plus negative a lambda. So from that we can get c cos a lambda t plus with d sine a lambda t, and then we will get cn cos a lambda nt plus dn sine a lambda nt. So note that from the part 1 where Amirul Syaqirin told about the lambda n equals to n pi over L, so we replace lambda n to n pi over L, and we get cn cos a n pi t over L plus with dn sine a n pi t over L. From that we have to do for un, where xt is equals to xn and tn equals to from the, for the equation where bn sine n pi x over L times with cn cos a n pi t over L plus with dn sine a n pi t over L. Now note that when you are expanding this equation, you will come across for the constant variable for bn times cn. You can simplify it by letting Bn Cn equals to En, and Bn Dn equals to Fn. So we will get En cos An pi Col plus with Fn sin An pi Col times with sin n pi Xol. From the superposition principle, superposition principle state that the sum of two or more solution is also a solution where, since wave equation is a linear homogeneous differential equation, the total solution can be expressed as a sum of all possible solutions. So here we have sigma bracket En cos An pi Tol plus with Fn sin An pi Tol times with n pi Xol. So from that, we will by inserting the initial condition, we will get sigma En sin n pi Xol, and by applying Fourier sine series for En equals to 2L with the range of 0 to L over 2 dx sin n pi Xol dx plus with the range for L over 2L b bracket L minus x sin n pi Xol dx. Now next is we have to do tabular method, since when any function which is the product of two expression is when we use tabular method, and since we have more than two expression for this equation, we have bx sin n pi xl, and for this one we have bl minus x sin n pi xol. So we have to do tabular method for both of those. One is by doing differentiation for bx and integration for sin n pi xol, and then differentiation for bl minus bx, which is the expression after expanding the bl minus x, and integration for sin n pi xol. So from the tabular method, we get the equation for 2 over L bracket of negative bxl over n pi cos n pi xol plus with bl square over n square pi square sin n pi xol, the range of 0 to L over 2, plus with negative bl square plus bxl over n pi times with cos n pi xol minus bl square over n square pi square sin n pi xol with the range of L over 2 until L. So from the equation, by expanding the equation, we will get 2 over L bracket negative bl square over n pi square cos n pi over 2 plus bl square over n pi square sin n pi over 2 plus with bl square over 2n pi square cos n pi over 2 plus with bl square over n pi square sin nx over 2, and finally we will get 4bl over n square pi square sin n pi over 2. Now differentiation equation with respect to t, earlier we did was our differentiation equation with respect to n. So we have sigma an pi over L En sin an pi t over L plus with an pi over L Fn cos an pi t over L times with sin n pi x over L. By inserting the value for ut where x0 is equals to equals to 0, we will get an pi over L Fn sin n pi x over L, and by applying the Fourier sine series, we will get 2 over L with a range of 0 to L fx sin n pi x over L dx. Since fx is 0, we will get Fn is equals to 0. And finally, substitution for En and Fn into uxt. By substituting, we will get the final answer, which is sigma 4 dl over n2 pi square bracket of sin n pi over 2 cos an pi t over L sin n pi x over L. That is all, and thank you. The question 2 will be continued by Mr. Firas and Muhammad Izani.
Assalamualaikum. My name is Muhammad Mirza Firas bin Muhammad Jamil. My matrix number B01221 0272. Okay, today I'm gonna explain about question 2A. This is the question given, and then we convert it as M, and we make it as homogeneous equation equal to 0, and then we get conjugate function because at the behind we got I, and then we make it as ODE equation. And for question 2C, this is the answer. This is the question given. We need to combine A and B. This is we get from equation A and we get from B, and then we combine and become this. And then from the question, we need to differentiate it, and then we got like this, and then we need to make it eliminate method. We get equation 1 and we get equation 2, and then we need to substitute equation 1 and into 2. We get the answer like this, and we need to get the answer as AN and BN. AN, we go like this, become equation 3, and then we need to substitute again equation 3 into equation 1 to get BN. That's all from me. Thank you.
Ya, Assalamualaikum dan salam sejahtera. Nama saya Muhammad Izani Hafizi bin Ishaq. Seterusnya, saya akan menerangkan soalan 2B, di mana soalan 2B ni dia minta untuk kita plot dan buat graf berdasarkan nilai yang diberi. Okay, di sini saya telah buat dan ini hasil graf saya, dan graf ni adalah odd function dan Fourier sine series. Okay, next kita pergi kepada pengiraan dia. Okay, untuk Fourier sine series, dia punya formula ialah Bn sama dengan 2/L integrate 0 hingga L ft sin n pi t per L. Okay. L ni dia refer sebagai interval di mana L sama dengan pi. So, Bn sama dengan 2/pi integrate 0 hingga pi t sin nt dt, di mana kita akan menggunakan tabular method. Kita akan differentiatekan nt, differentiate nt jadi pi, differentiate pi jadi 0, dan kita akan integrate sin t jadi negatif 1/n cos nt. Kita integrate negatif 1/n cos nt, ia akan jadi negatif 1/n squared sin t. Okay, then kita masukkan, selepas kita integrate dan differentiate, kita masukkan ke dalam equation. So 2/pi negatif pi t per n cos nt plus n per n squared sin nt bracket pi to 0. Okay, next kita masukkan balik lepas kita differentiate and integrate. 2/pi kurungan negatif pi per n darab dengan pi cos nt plus pi per n squared sin nt minus 0 cos 0 plus pi per n squared sin 0. Sin 0 is equal to 0, cos 0 is equal to 0. Sin nt is equal to 0, cos nt equals to negative 1. So the answer will be negative 2 pi per n, negative pi squared per n bracket negative 1 kuasa N. So, kita darabkan, kita potong dulu pi and kita mudah simplify, and dia akan jadi negatif 2 pi per N bracket negatif 1 N. Okay, after that kita apply Fourier sine series. So kita akan masukkan semula ke dalam dia punya equation. So the last answer is 2 pi per N bracket negatif 1 N plus 1 sin NT. Terima kasih.